Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this review of week 1. So we're looking at differential calculus, which is telling us the rate of change or gradient of a function. But a function like this has a different gradient at every single point. So what we need to do if we want to find, say, the gradient at this point, we pick another point on the line and we draw a line through those 2 points. To find the gradient at this green point here, I'm going to find the gradient of the black line. But the black line is only a good indication of the gradient here if the 2 points are very close together. So this formula is just 2-point formula, y2 minus y1 over x2 minus x1. The limit as h approaches 0 just says I want the 2 points to be as close as possible together. So if I want to differentiate this using first principles, so first I need to find f of x plus h. So to do that, I take my x and everywhere I see an x, I replace it with x plus h. So now I'm going to expand this. You might need Pascal's triangle to help you find the coefficients, but I get this, and then I'm going to substitute into this formula here. So I have limit as h approaches 0, f of x plus h minus f of x over h. So these two x cubes will cancel each other out. I should be left at this point with only terms involving h. I can't substitute h equals 0 here yet because then I'd be dividing by 0. So what I'm going to do is first divide each term by h one by one. So I get 3x squared plus 3xh plus h squared. So now I can substitute h equals 0. These just become 0. I'm left with 3x squared. So that's the answer using first principles. That was a long time. Quick way, I could have just moved the power to the front and decreased the power by 1. And that's what I'm going to do here. If I want to differentiate this function, not going to use first principles, takes too long. Move the power to the front, decrease the power by 1. So the derivative of minus x is 1. It still follows the same rule because this is x to the power 1. So root x is x to the power of a half, so I can use the same rule. I'm going to move the power to the front, decrease the power by 1. 4 over x squared, that is actually 4x to the power of minus 2. So to differentiate this term here, I move the minus 2 to the front. Minus times a minus is a positive, and I decrease the power by 1. And when you're differentiating, constants vanish. The derivative of 5 is equal to 0. And I can just simplify this expression here. X to the power minus half. Negative power goes on the bottom of the fraction, change it to a positive power, which is also what I did here as well. All right, let's now look at some applications. So an application of differential calculus is kinematics, displacement, velocity, acceleration. So if this is the displacement function, x the distance, t the time in seconds, velocity is just x dash t. Velocity is the rate of change of displacement with respect to time. So remember, velocity is like speed, except it can be negative because the negative gives it a direction. A negative velocity just means you're traveling in the opposite direction. So for example, if I were to substitute t for 0, I'd get 24. So that means the car is traveling at 24 meters per second to begin with. You know, x dash 1 would be 24 minus 6, which is 18 meters per second. So the car's traveling at 18 meters per second after 1 second. So acceleration is the derivative of velocity, or if you like, the second derivative of displacement. So to get acceleration, I just differentiate this function here, and here I just get minus 6, and it's meters per second squared. So the acceleration is negative because the car is slowing down by 6 meters per second every second. All right, let's now look at the chain rule. So this is the chain rule up here, also called function of a function rule because we use it for functions like this, where we have a function of x and then raising to the power of 30 is another function. So to differentiate it, we're going to do something similar that we've already done. We're going to move the power to the front and decrease by 1. But what's new in the chain rule, this du dx, see, we let u be the first function in the brackets. So we need to times by the derivative of what's in the brackets. So the derivative of x squared plus 3 is 2x. That's the new part. And then this just simplifies to 60x, x squared plus 3. All right, let's look at the second one. A little more tricky because the x's are on the bottom of the fraction. fraction, and there's also a square root. We need to make it look a bit more like this. So to clean this up, on the bottom it becomes x minus 4 to the power of 5 over 2. So remember, fractional powers. This top number tells you the power, the bottom number tells you which root. If it was a cubed root, this would be a 3. So remember, if something's on the bottom of a fraction, you can move it to the top, but you have to change the power to negative. So now this looks in the same form as the first one. We're going to move the power to the front. We're going to decrease the power by 1 and times by the derivative of what's in the brackets. In this case, the derivative of x minus 4 is just 1. So often when you have a negative power, you'll be asked to write your answer as a positive power. So on top, 3 times minus 5 is minus 15. On the bottom, we have a 2. And we'll write it as x minus 4. Now we're changing it to a positive power. So a negative power, move it to the bottom of the fraction and make the power positive. All right, let's look at a worded question. So worded questions like this were causing a bit of problem. Radius of a sphere increasing 0.2 centimeters per minute. How quickly is the surface area increasing when the radius reaches 5 centimeters? So we're looking for the rate of change of the surface area with respect to time. Now we are told the radius is changing at 0.2 centimeters per minute. We're told how quickly the radius changes with respect to time. So to complete the chain rule, I need an A here on top. So I need dA here, and I want to get rid of the dr. So it's sort of like I'm getting rid of them like that. So we can find dA dt by finding these two quantities. So we know dr dt is 0.2. We were told that in the question, 0.2 centimeters per minute. Now dA dr, we can figure that out. We know the surface area of a sphere is 4 pi r squared. That's just a formula we know. So if I differentiate this with respect to r, I move the power here to the front. 4 times 2 is 8, and decrease the power by 1. So dA dt is dr dt times dA dr, which is this. Now we're told that the radius is 5, so I'm just going to put a 5 there. And so putting that in our calculator, we get the answer. I think it's about 25.13, because it's surface area to be centimeters squared per minute, and because we were told in the question, centimeters per minute. All right, that's all for week 1. Keep your head up. You're doing a great job. This has been the luckiest maths teacher in the world. Have a great day.